Hello everyone, Namaste. Welcome back to the course Introduction to Infrastructure Asset Management. This course is offered under MOOCs, an initiative of Government of India. In the last week, we continued our discussion on infrastructure decision making. We discussed this framework where we focused on performance modeling. We also discussed development of alternatives, and we saw that in order to make a decision, we need to keep in mind the policies, goals and the budget which is available. We talked about two aspects around budget planning and budget programming. In this particular week, the focus will be on decision making. Here, we will discuss economic decision making, multi-criteria decision making and multi-objective optimization. Before we move towards decision making, it is important to acknowledge that any budget programming or budget planning which we are doing or any alternatives which we are creating, we should keep in mind that we look into a life cycle perspective. That is, the decision we are taking is not a one-time decision. We need to account for what will be the impact of this decision throughout the life of the infrastructure. So, this particular lecture, which is the first lecture in week 5, here we will focus on life cycle perspective in infrastructure decision making. We are continuing with our discussion on decision framework for infrastructure asset management, where life cycle perspective will be discussed. What is life cycle perspective and why do we need it? The idea is any infrastructure goes through following stages. We start with initiation, then we move towards design phase, then we move towards construction phase. Once the facility is constructed, we move towards operation and maintenance. During operation and maintenance, we use the facility. At the same time, we do routine maintenance. Finally, once the life of an infrastructure has reached, we dispose it off. So, there is a salvage value associated with it. If you look into this particular diagram, you will realize that for most of our infrastructure projects, initiation to construction typically takes 5 to 6 years. For example, we might decide to construct an infrastructure, we design it and then we construct it. It takes around 5 to 6 years. However, we use this facility for a much longer time, say typically 30 to 40 years. The design life of a building will be around 60 to 70 years. For some other infrastructure, the design life could be around 30 to 40 years. And finally, we decide to dispose it off. So, it is important to note here that whatever decisions we take during this phase, which is the design and construction phase, has an impact on how much maintenance cost. So, it is important to note that whatever decisions we take during the design and construction phase will have an impact on the use of the property or the infrastructure and the maintenance required on that particular infrastructure. So, it becomes important that we keep in mind a life cycle perspective when we take any decision, because the decision which we take say in the second year might actually have an impact on how this asset needs to be maintained for the next 30 to 40 years. It is important that we keep life cycle perspective in mind. Research in this area have found that infrastructure assets with proper life cycle planning can achieve significant cost savings and they can also improve sustainability outcomes. Along with the initial design and construction cost, which might look higher, operation and maintenance cost is also an important constituent of the whole life cost. That is, the operations and maintenance cost also are a significant part of the total project's cost. Thus, it is important to keep in mind a life cycle perspective when we take these decisions. Let us discuss this with the help of two examples. Say you have two alternatives, design strategy A and design strategy B. In case of A, you predict that if you choose A, you will not need to do any maintenance. At year 15, you will need to do a major maintenance here, and then for the next 10 years you do not need to do anything. This is alternative A. Alternatively, you have another alternative B, where you predict that if you choose alternative B, it will follow this dotted line, where you will need to do maintenance at the 5th year. Again, it will recover its performance, but then at the end of 10th year, again its performance will go down. You will again need to do a maintenance here, and then again the maintenance will come down. So, if you see here, if our period is 25 years, for alternative A, we are required to do maintenance only once. However, for alternative B, we need to do maintenance 1, 2, 3 and 4 times. Now, it is possible that the cost required for alternative A might be higher compared to the initial cost required for alternative B. Also, the maintenance cost might be different. So, here the cost required to do this particular maintenance might be different from the cost required to do this particular maintenance. So, the idea is, when we choose alternative A and alternative B, we should not only focus on initial cost, but we should also focus on what will be the cost of maintaining it throughout its life of 25 years. So, an appropriate design strategy will govern what type of maintenance will be required throughout the life. Another life cycle perspective could be around the choice of maintenance. Let us look at that example. So, for example, for a given asset, you have multiple maintenance options. One of them could be you do no maintenance. This is the case which we have already discussed earlier. If you do not do any maintenance, the performance will come down here, and then you will need to do a heavy rehabilitation. Say this is year 20. Alternatively, you have an option that, say on year 15, you can do a preventive maintenance. The preventive maintenance will improve the performance, and then it will go down like this. Here you might decide to do a light rehabilitation at year 25. So, the performance will go up and then go down like this. So, you have multiple options here. First is you do no maintenance followed by a heavy rehabilitation. Second option is you do preventive maintenance followed by light rehabilitation followed by no maintenance. Or third option is you do preventive maintenance, then you do not do any light rehabilitation, but you do a medium rehabilitation. Each of these are suitable maintenance strategies. In deciding which strategy to choose, we keep in mind the total life cycle cost. That is, we want to understand what will be the total cost of choosing one alternative over another. It is important to note that cost is just one part of the problem. Along with cost, we also need to keep in mind the environmental and social impacts of our decision. So, when it comes to life cycle perspectives, there are two key aspects. First is the life cycle cost analysis, where the initial cost, operations and maintenance cost, disposal cost and replacement cost are studied. Second is life cycle environmental analysis, where we try to understand the raw material extraction, its impact on the environment, the manufacturing, production, construction, its impact on the environment, use phase, whatever waste gets generated, its impact on the environment, and if there is any recycling potential, what is the overall impact on the environment. So, when it comes to life cycle perspective, we need to keep in mind the cost aspects, the environmental aspects, as well as there are some social considerations which we need to keep in mind. In this lecture, I will talk about these two aspects in detail. Let us start with life cycle cost analysis. It is also known as LCCA. The goal of LCCA is to find a systematic approach which can evaluate total economic cost of an infrastructure asset by analyzing its initial cost and the discounted future expenditures throughout the service life of an asset. Here, LCCA will include initial cost, maintenance cost, user and social costs, as well as disposal costs. We have already discussed in the first week that the concept of time value of money is utilized here to bring all costs either in present terms or in future terms. That is, when I say the word discounted, we try to bring all the values in either the present terms or future terms. I will briefly discuss this again. As we have seen in the first week, time value of money deals with the idea that the value of money today is worth more than the same amount of money at a future date. That is primarily because of the earning potential of the money and inflation. We have also discussed how interest rate and discounted rate impacts how we convert a given cost at a future date to current terms. LCCA, as we have discussed, will include the cost of acquiring an asset. Additionally, it will include the cost of owning the asset, that is the maintenance and operations cost. Additionally, it will include the cost of disposing an asset, salvage costs. We understand that all these costs will be incurred at different stages of a life cycle. Now, to compare two alternatives, we need to find a way so that we convert them into a single term. Cash flow diagram is used to do that. We have already seen that a cash flow diagram looks something like this, where you mark all your costs on one axis. So, outflow is on one side of the axis and all your revenues are on the other side. So, this is negative, that is money going out, and this is money coming inside. Now, once we have a cash flow like this, we try to find an equivalence number which represents this entire cash flow in a single term. Now, we might have another cash flow like this for another alternative. For that alternative also, we do the same thing. The idea is simple, that all your costs, incomes and revenues are plotted with the help of a cash flow diagram. We are using this information to basically calculate life cycle cost, but we do not want to use multiple numbers to represent that. So, we basically discount all the future costs and bring them in today's present value, and then we try to compare two alternatives. So, let us see how we can utilize cash flow diagram to calculate life cycle cost for an asset. Here I have an example of a hostel building. This hostel was constructed in 1960. So, we can assume that there was an investment in 1960. Then it is given to us that every 5 years they did routine maintenance on this. So, 1965, 1970, 1975 and so on, there will be some maintenance costs on this particular hostel. Then in 2002, they have done renovation of bathroom and they have done some new construction. In 2004, they have renovated rooms. So, again there will be some cost associated with it. In 2005, they have done some work on peripheral walls. Again there will be some cost associated with it, and so on. In 2014, they have changed all the bathroom fixtures. So, again there will be some costs. In 2019, they had to do external weather coating and renovation again. So, there might be some more costs. So, now for this particular hostel building, we have a cash flow diagram like this, where we know what was the initial cost and what was the maintenance or rehabilitation cost at different years. Now, say there was another hostel like this, in which the initial cost was slightly different. I am marking that with a green color. However, the cost of routine maintenance was higher, but they did not require to do any renovation of bathroom in 2002, 2004 or 2005. Only in 2007 they had to do some light rehabilitation. However, say in 2014 and 19 they had to do the same works which were required in the earlier hostel. So, now for this particular hostel we have a slightly different cash flow diagram. Now, the question is, which hostel is better in terms of LCCA, life cycle cost analysis? The problem is, we have costs which are distributed across the life of the infrastructure. So, we cannot directly add them to find the total cost. That is where we have seen that we can use concepts like net present value to find an equivalent number which can be used to find a representative number which can represent a given alternative. So, for both the alternatives A and B, we will have some life cycle cost. Say for A, it might be around 120 Cr, and for B, it might be around 110 Cr. To find the equivalent number, we try to simplify the cash flow. In the first week, we already saw that there are different methods to do that. Based on the type of payment, we could utilize any of these factors to basically bring down the cash flow value into a single term. We also saw that net present value can be used to determine the sum of all present values of the cash flow. We could utilize NPV to basically make decisions like this. Say if there are two alternatives, alternative A and alternative B, each one of them have different initial costs, they also have different O&M costs, they have different salvage values. We have seen that net present value can be used to determine which alternative is better. Thus, from a life cycle cost perspective, it is important that we consider all the factors while taking a decision. Let us quickly summarize what are the key factors which we need to keep in mind from cost point of view. LCCA factors which are worth considering include choosing an appropriate design strategy so that your initial costs are reduced, at the same time your future maintenance and rehabilitation costs are also less. Second important aspect is timing of activities. When do we have the required money, and accordingly plan when should we do maintenance and rehabilitation. Timing is an important aspect where we are deciding based on the available budget and all the assets which need maintenance, what is the right time to maintain a given asset. We also need to keep in mind the total analysis period, for how many years we want to use an asset. We also need to account for what is the nature of activity, what is the type of maintenance we want to do. When we talk about costs, it is not just the agency cost, it also includes two other types of cost which we have discussed, that is the user cost as well as the social costs. We need to consider all these factors together to finally account for the life cycle cost of an asset. Now, in addition to cost, another important aspect is the environmental costs or the environmental assessment. LCA, life cycle assessment, is commonly used to determine environmental impacts of an infrastructure. Life cycle assessment provides a mechanism for systematic evaluation of environmental impacts throughout the life of an infrastructure. LCA requires comprehensive data collection, where we try to define systems boundaries and we try to understand what were the raw materials used, what is the energy use, what is water use, what were the resources required, what were the emissions, what was the waste generated. Also, if there were any byproducts being generated. We account for all of these to understand what was the overall impact of this particular infrastructure on the environment. It helps us in identifying hotspots where environmental impacts are concentrated. This will help us in coming up with targeted interventions which can help in impact reduction in the future. Our goal is that the infrastructure should not negatively impact the environment. We want to come up with strategies which reduce the overall impact on the environment. It is a difficult exercise, but all of us want to move in a direction where economic development or infrastructure development is not at the cost of environment. LCCA is a mechanism which is used to basically understand what is the impact of the infrastructure. Here we consider all the different perspectives. For doing comprehensive life cycle assessments, we need to account for all the phases, right from the production phase, construction phase, use phase, demolition phase to recycling phase. This is known as a cradle to cradle approach for doing life cycle assessment, where in production phase we try to understand what were the raw materials extracted, what was the cost of transporting them, what was the cost of manufacturing any construction material, if we are doing any prefabrication, what was the environmental impact of doing that. Then when we come to construction stage, we try to understand what was the environmental impact of all the construction activities. Also, if there was any waste generated, what was the environmental impact of transporting it. Now, from construction stage, when we move to operations phase, here we try to understand what is the environmental impact of operating an asset and also what is the environmental impact of maintaining and renovating it. Finally, when the design life is complete, we move to deconstruction stage, where we try to demolish the infrastructure. We see what is the environmental impact of deconstructing this particular asset. Whatever waste is getting generated, what is the environmental impact of transporting it. Finally, we move to a stage of waste processing, where we try to recycle all the waste which gets generated. However, recycling itself has some environmental impact. So, we try to understand that. Then once the recycled products are created, we see can they be transported back to another construction site. So, this arrow here represents reusing the material again. So, we try to account for that as well. However, there might be some waste which cannot be recycled again, it must be disposed of. So, this goes to landfill. So, when it comes to doing a life cycle assessment, we have to account for all the phases and all the activities which we do, which has an impact on the infrastructure. I have taken this diagram from a paper of my student who has done life cycle assessment of a hostel building, where we account for all the phases right from production to the recycling phase. This is known as cradle to cradle approach, where you also account for what will be the life cycle assessment, where you also account for what will be the benefit of reusing a recycled material. I hope the idea is clear that life cycle assessment or life cycle impact assessment is focused on understanding the overall impact on the environment. However, it gets difficult to quantify this with the help of a single parameter. In literature, there are different impact categories which are used to evaluate life cycle assessments. We could use the total embodied energy, or we could use the total global warming potential, we could use ozone depletion potential, acidification potential, photochemical ozone creation potential, and so on. These are just few impact categories. When it comes to understanding impact on the environment, we could use any of these or a combination of these. The idea here is that a particular infrastructure will have multiple activities throughout its different phases. For each of these phases and for each activity, we want to understand the environmental impact with the help of, say, global warming potential. For each activity, we will find a number and then we will add all those numbers to find the total global warming potential of that particular infrastructure. This becomes important especially when the asset manager has to decide which maintenance strategy should I choose. For example, here we have already seen that there are different possibilities. Each of these possibilities will have their own environmental costs. For example, doing preventive maintenance might require different types of material, while on the other hand, doing a heavy rehabilitation might require slightly different types of material. Each of those materials will have different environmental impacts. So, it is important that as a decision maker, when we are choosing a maintenance strategy, we also account for environmental impacts. Choosing one maintenance strategy over another, we might see that in addition to the raw materials which are used, there are some other aspects which should also be considered when estimating the total environmental impact. For example, here let us see this case of no maintenance versus a preventive maintenance. Now, in case of no maintenance, although there are no materials which are required for doing any maintenance till this point, so the environmental impact might be lower. However, when we do a heavy rehabilitation, we might need a lot of materials. Additionally, say if this is a road and there are vehicles which are driving on this particular road. Now, as the road condition deteriorates, the vehicles might need to move at a lower speed, which might come at the cost of more fuel consumption. Since we are using more fuel, again we might say that the GHG emissions will be higher. So, it is not just the materials which are used for maintenance and rehabilitation. The users who will be using the facility, they will also incur some day-to-day costs. For example, say if you have not insulated a building properly, the user might have to use AC continuously in hot weathers. Using an AC will come at its own environmental cost. So, in addition to the materials which will be used for maintenance and rehabilitation, we also keep in mind the user who is using the facility. What are the activities the user will undertake and what will be the environmental impact of it. So, a user driving on 30 kilometers per hour versus 60 kilometers per hour, they will have different fuel consumptions. We need to keep that in mind. Or a user not requiring AC during hot weathers because insulation of a building is done properly versus a user which is required to use the AC for 24 hours will have different environmental impacts. So, LCCA needs to account for all those aspects as well. So, going back to this table which we had discussed, that we need to create a maintenance schedule for each asset under our purview. Basically, we need to choose different maintenance strategies each year. When we do that, it is important that we integrate a life cycle perspective from cost point of view, from environmental point of view and from social point of view. We account for all of these together when we choose an appropriate maintenance strategy for an asset. Now, having discussed life cycle perspective, in the next lecture we will discuss different decision making techniques which can be utilized for infrastructure decision making. Now, here are some of the important references around this topic. Thank you. Thanks for listening.